In this video, we are going to demonstrate the integration of four integrand functions shown on the screen by using the integral table. Let us look at the first example of how to apply the integral table to solve the integrations seen on the screen. In order to obtain the solutions to the integration as shown here, we go through the integral table to find if we can find any form that match with the integrand functions we are integrating, namely x sitting on top of an linear function of ax plus b. So if you look at the integral table, you find item 24, which is just in the form of the function we are looking for. So let me copy this expression here. The function we want to integrate is in the form of x over 2x plus 5. So you can match the integrand of x over 2x plus 5 with the integrand in item 24. The values of 2 plays a role of a and the values of 5 play the role of b. Therefore, you can straightforwardly write down the expressions of the solution, which is x over a. Here a is 2 minus b, where b is 5, over a squared, which is 4, times the log of the absolute values of ax plus b, which is just 2x plus 5, plus an arbitrary constant. So that is how you obtain the integral to the function x over 2x plus 5 by referring to item 24 in the integral table. In short, you simply refer to this formula and reproduce the answer by writing down the corresponding term provided in item 24. As simple as that. For the next example, we look at the integrations of 1 over x times square root of 2x plus 4. The function contains a denominator made up of a product between x and a square root of 2x plus 4. So we scroll through the integral table for a suitable integrand that could give us the integral results we are looking for. The basic forms does not contain what we want. We are looking for an integrand that has a function with a form of ax plus b. We will be looking at this integral table again, that is meant for function that involve a form of ax plus b. Here it is. The item 29a is the integral table that will suit us for the function we are integrating. This is the function we want to integrate. It is very obvious that 2 here plays the role of a, 4 plays the role of b. So we just have to copy the expressions in item 29 term by term to the right hand side of the integration we want to find. So we have 1 over square root of b. Square root of b is 2 because b is 4. So we have a log of the absolute values of a ratio made up of square root of ax plus b minus 2 and square root of 2x plus b minus 2 plus an constant. Sorry, I have to make a correction. It should be a plus 2 instead of a minus 2 in this expression. So that is the solution to the integrations of 1 over x times square root of 2x plus 4. The third example is very similar to the example we see before, but here the argument inside the square root in the denominator is of the form ax minus b instead of ax plus b. So we again refer to the integral table which involve ax plus b and look at item 29b. We can see here that even though the integrations is very similar to the previous one, where the argument ax plus b is replaced by ax minus b, the result of the integration looks very different. To obtain the solution to the integrations of this function, we just copy down the right hand side of the item 29b term by term and write down 2 over square root of b. 2 is a, b is 4. So square root of b is just 2 arctangent of the square root of 2x minus 4 divided by 4 plus a constant. More compactly, arctangent of square root of x over 2 minus 1 plus c. That is the solution to the integrations 1 over x times square root of 2x minus 4. This has been achieved by referring to the item 29b in the integral table. We look at the fourth example to demonstrate how to use the integral table. The function we have here is similar to the previous example, but the denominator contains the product of x squared to the square root instead of product of x with a square root. The integral table we should be looking for is the one that contains ax plus b. Previously, we have been using 29a and b, but in this case, the item that we should be referring to is 31. Where it contains the right form of the expression that is relevant to the integration we want to perform. In this case, the formula for 31 does not distinguish between the situation of ax plus b from ax minus b. This is unlike the case of 29a and b, where the integrations involving ax plus b in the square root and ax minus b in the square root are distinct from each other. In other words, for the integrations of this function with an argument in the square root ax plus b does not distinguish whether the argument in the square root is ax plus b or ax minus b. This is different from the case of 29a and b. So in this case, we would identify a with 2 while b to be identified with minus 4. With this, the term minus square root of ax plus b over bx is simply then written as minus square root of the same argument, 2x minus 4, divided by minus b, which is minus 4 times x, minus 2 over 2, b is minus 4, integrating the x over x of square root of 2x minus 4 plus c. So let us simplify this further. We then arrive at the second line of the equation, which is highlighted in yellow. You will find that the integrations that involve a square in the denominator has now been reduced to an integrations that involve only an x without a square. So the complications of the integration has been reduced to a more simplified version. We have to proceed to finish up the integrations of this term, which has been already obtained in the previous example. In the previous example, we have already established these results for the integrations involving only x in the denominator. Therefore, we can now obtain the full solutions to the integrations of the original integration we want to perform with an square in the denominator. We just have to replace the integrations involving the x term in this line to the expression I'm going to write down now. Copy the first term from the previous line, add to 1/4, multiply with the expression here, arctangent of x over 2 minus 1 plus and constant c. So that is the solution to the integrations where the denominator is x squared multiplied with square root of 2x minus 4. As a conclusion to this video, we have demonstrated how to perform the 4 integration as shown in these slides using integral table. We will continue with one more example in the next video.